Okay, now in the last video we did a review of arithmetic sequences. In this video we'll do a review of geometric sequences. Now, what's the difference between arithmetic and geometric? Remember, if you have arithmetic sequence, then there's a common difference between the terms. If you have a geometric sequence, then they have a common ratio between the terms. And we'll just look at these four examples before we start on some sample problems. But the idea is just to show you that these things really are geometric. If I start with, we'll use this first example here. The first term would be a sub 1. Second term is a sub 2, a sub 3, and so on. Well, to find the ratio between the terms is just the second term divided by the first term. So in this example, it would be 9 divided by 3, which would be 3, and that is the common ratio. And you can see that it works by starting with the first term. 3 times 3 gives you 9, times 3 gives you 27, times 3 gives you 81, and so on. Now, to show you some variations, in this case it was a positive integer. It could be a fraction, could be a decimal, could be a negative number. Let's take a look at a couple of these other ones. So this is, again, the first term is 12, the second term is 6. So on this one, the ratio would be the second term divided by the first term, which would be 1/2, and that's going to be the common ratio. So it doesn't have to be a whole number. Now in this case, the sequence decreases, so 12 times 1/2 gives you 6, times 1/2 gives you 3, times 1/2 gives you 3/2, and times 1/2 gives you 3/4, etc. So it could be a fraction. Now it also could be a decimal. Let's take a look at this one. Again, there's the first term, there's the second term. The common ratio is just the second term divided by the first term. So in this case, it's just 1.6, and that's going to be the common ratio. So if you multiply them, starting with 1 times 1.6 would give you 1.6. Then times 1.6 would give you 2.56. Times 1.6 would give you this, and so on. So it could be a decimal. And then finally, it could be a negative number. Let's take a look at that one. So the ratio would be the second number divided by the first number, which would be a -3. So you got the common ratio is a -3. And then just to test it, 2 times a -3 gives you a -6 times a -3. Now, two negatives make a positive, so it alternates in sign. Then times a -3 switches back to a negative number, then times a -3, and so on. So there's just 4 examples of some geometric sequences with different types of ratios. Now let's take a quick look at the rules that will apply to this. Okay, so if we want to find the nth term of a geometric sequence, you've got a couple of options here. If you know the first term and the ratio, you can find the nth term. Or if you don't know the first term and you just know some term somewhere in the middle of the sequence, then you can use this variation to find the nth term. And then finally, the common ratio is always just either the second term divided by the first term or any 2 consecutive terms, the ratio of them. So with those rules, let's look at a couple of problems now. Okay, the first one looks like this. Find the 12th term of the geometric sequence, and the sequence will be given in red here. So what we've got, now I would suggest go ahead and label these just like we did in the arithmetic sequence videos, but I'm going to call this a sub 1, this would be a sub 2, a sub 3, and so on. Now I want the 12th term, so somewhere out here, and I'll just kind of draw a line for it, is a sub 12, and I want to know what is this 12th term. Now to find that, you're going to have to go back to the rules, and let's take a look at these. So what the rules say is this, is to find, if I know the first term, and I'm looking for the 12th term, if I can find the common ratio, then I can use this formula to find the 12th term. So the first step is going to be to find the common ratio. So what that's going to look like, and we'll go ahead and put our steps down right here. So this will be step number 1 is going to be to find the common ratio r. And to do that, again, just looking at the rules, the ratio is just the second term divided by the first term, or any two consecutive terms. So the common ratio is going to be the second term, which is -6, divided by the first term, which gives me a -2, and that's going to be the common ratio. So I've got r. So now you want to find the 12th term. So we'll go to step 2, and that's going to be to find a sub 12. Well, again, checking the rules, we now know the first term, you know the ratio. You can use this expression right here to find the 12th term. So we'll start with the rule, which says that a sub n is equal to a sub 1 times the common ratio to the n minus 1 power. So in our case, we're looking for a sub 12, and we know that a sub 1 is a 3. We know the common ratio is a -2, and we want to go to the 12 minus 1 power. So in this case, n would be equal to 12. Okay, so that gives you a sub 12 is 3 times a -2 to the 11th power. So a sub 12 would be equal to 3, and -2 to the 11th power would be -2048. And then if you multiply that by 3, you get -6144, and this is going to be the 12th term. So this 12th term up here would be -6144. So again, to find these, start by step number 1 is to find the common ratio by dividing the second term by the first term. Once you've got the common ratio, then you can use this formula. You've got the first term and the ratio, use this formula to find whatever term you're looking for. So there's a first example in which you knew the first term. Now what would happen if you did not know the first term? Let's take a look at that in the second example. Okay. Now, in this example, you want to do the following. You want to find the 8th term of a geometric sequence, but you don't know the first term, but you know the third term and the 5th term. So again, what I'm going to do is just draw a quick picture of this just to kind of see what it looks like. So what I've got is, I'll do it like this. I'll put a bar here. This will be a sub 1. I don't know what that is. Here is a sub 2. I don't know what that is. Here is a sub 3, but I know that that's a 3. Then I've got a sub 4. Don't know that one. And I've got a sub 5. I know that that's a 12. Then I'm looking at, here is a sub 6, a sub 7, and finally I want the 8th term, a sub 8. So this is the term that I'm interested in. But in this case, though, there's a problem, and that is if I go back to the rules, this formula right here requires me to know the first term. But you can use a variation of that formula. If you don't know the first term, but you know some term in the middle of the sequence, then rather than using a sub 1 and n minus 1, you can use a sub q and n minus q. So let's try that formula. Okay, so in this case, I'll set it up like this. This is going to be a sub q right here. So let me change colors here. This is going to be q, and this is going to be n. So I know the 5th term and I know the 3rd term, and I can use this to find the common ratio. So step number 1, I still need the common ratio between the terms. So it's going to be to find r. But this time I'm going to use this formula. So a sub n is equal to a sub q times r to the n minus q formula. So again, I don't know the first term, but I can still use this formula to find the ratio. So plug in the things that you know. A sub n will be, in this case, n is going to be 5. We're just going to put the numbers in first. This will be a sub 5 this would be a sub 3 times r to the 5 minus 3 power. Now plug in what you know. A sub 5 is a 12, a sub 3 is a 3, then I've got r squared. So 5 minus 3 would be 2. Now solve this thing for r. So that's going to give you 12 divided by 3 would be r squared. 4 would be r squared. Take the square root of both sides and you get a 2. But remember, it's a plus or a minus 2, and that's going to be important later on. So here is the common ratio. So now I know what the common ratio is. I can use this same expression. Again, I'll use this thing right here to find the 8th term. But this time I'll do this. I'll assume that this is going to be the q, and this is going to be the n. You can start and stop anywhere you want to. So this is going to be step 2. So what step 2 is find a sub 8. That's what I wanted. Well, again, I'll still use the same formula. So a sub n is equal to a sub q times r to the n minus q power. But in this time, this is going to be 8, and this should be an a, sorry. This would be a to the 5th times r to the 8 minus 5. So you can actually start n and q wherever you want to. Okay, I want to find a sub 8, and I know that a sub 5 is a 12. I know the common ratio. Now you'll have two variations right here. It could either be a positive 2 or a negative 2. So we'll kind of, at this point, split the thing into two possibilities here. In the first one, we'll assume that it's a positive 2. Then 8 minus 5 would be 3. So that gives me a sub 8 would be equal to 12. 2 cubed would be 8. And I get a sub 8 is a 96. So this term right here is going to be a 96. And that's going to be the answer to the problem. Now, if you actually do this, watch kind of what happens here. If this is a positive 2, if r is 2, you'd have this. 3 times 2 would give you a 6, times 2 would give you a 12, times 2 would give you a 24, times 2 would give you a 48, and then finally times 2 would give you a 96. So actually 96 is going to be the answer. But just what's a little bit interesting about this is that there's actually a second variation on this, and let's take a look at that. Suppose that rather than using the positive 2, you had used the negative 2. So starting at this step, we'll go a sub 8 is equal to a sub 5 would be a 12. Let's put in the negative 2 cubed. Then in that case, you'd get a sub 8 is equal to 12 times a negative 2, well, cubed. So let's go ahead and run this. So this would be 12. Negative 2 cubed would be a negative 8. And that's going to give you a sub 8 would be equal to a negative 96. Now let's see what that actually means. If you started, once again, here is, let's just go ahead and we'll start with a sub 5. Oh, we'll start with a sub 3. Then here is a sub 4, a sub 5, a sub 6, a sub 7, and a sub 8. Well, this one you know is 3. This one you know is 12. And let's see what happens this time. If you used a negative 2. So we'll go back, and this times a negative 2 would give me a negative 6. Times a negative 2 would give me a positive 12. Times a negative 2 would give me a negative 24. Times a negative 2 would give me a positive 48. Times a negative 2 would give me a negative 96. So actually, there are two answers to this problem. Depending on whether you had a plus or minus 2, either the 8th term could be a 96, positive 96, or the 8th term could be a negative 96. So you have to account for the fact that it could be plus or minus, and either one of those two works. Neither answer is better than the other answer, but either one will work just fine. So just kind of be aware of the fact that the ratio itself could be a positive or negative, in some cases leading to two separate answers. So that's an example of a problem where you know not the first term, but you know some couple terms in the middle. And again, it's a variation on this formula. If you know the first term, use this formula. If you just know any two terms in between, you can use this. And in this case, it led to two answers because the ratio could either be positive or negative. And let's take a look at one last example. Okay, in this case, it wants to know, find the missing terms of this geometric sequence. Now, sometimes you'll get this if it says find the missing terms. That's the same thing as asking you to find the geometric means. So the geometric and means is the same thing as the missing terms in a geometric sequence. Now, in this case, we'll go ahead and label things again. So what I know the first term. Here would be the second one, the third one, the fourth one, a sub 5, a sub 6, and finally out here, a sub 7. So what I want to do is to find the terms in between. And to find those, I've got to find the common ratio. But let's go back to the rules. To find the common ratio, if I happen to know the first term and the second term, it's easy to get. But in this current case, in our problem, we know the first term and the 7th term. So to find the common ratio, back to the formulas again, rather than using this formula, we're going to have to use this formula up here. We know the first term and the last term, but we can use that to get the common ratio. So let's see what that looks like. So in this case, it will be this. We'll go with step number 1 over here. So step 1 is to find the common ratio. Now to do that, we'll use a sub n is equal to a sub 1 times r to the n minus 1 power. Now let's plug in the things we know. We'll use a sub 7 is a sub 1 times r to the 7 minus 1 power. So a sub 7 is 128. A sub 1 is a 2. The common ratio is what we're solving for. This will all be to the 6th power. So divide both sides by 2, and you get 64 is equal to r to the 6th power. So go ahead and raise both sides to the 1/6 power, would be equal to r to the 6th to the 1/6 power. These 6's will cancel out, leave you with an r, and this would be the 6th root of 64, which we'll go ahead and write it like that. So the 6th root of 64, and the 6th root of 64, of course, is a 2, and that's going to give you r. But again, remember this is a plus or minus 2. It could be either one. So now that you know the common ratio, you can take this ratio and fill in the missing terms. So starting with the first one, times 2 would give you a 4, times 2 would give you an 8, times 2 would be 16, times 2 would be 32, times 2 would be 64. And if you've done everything right, times 2 should wind up with a 128. But just like that last problem, you also have to consider the possibility of the negative. That might work also. So let's reset things here again. Here's 2. Here's 1, 2, 3, 4, 5, and here's the last term, 128. But this time, let's try the negative 2. So if you multiplied it times a negative 2 would give you a negative 4. Times a negative 2 would give you a positive 8. Times a negative 2 would give you a negative 16. Times a negative 2 would give you a positive 32. Times a negative 2 would give you a negative 64. And then finally, times a negative 2 would give you this. So in this case, the answer is actually going to be both of these together. So either sequence works just fine. So in this case, when you solve for r, if it gives you a plus or minus, there's a possibility that both sequences work. And again, in this case, both sequences are equally fine, and you get two solutions to the problems. So we'll go back and take one quick look at the rules again. But anyway, if you're working with a geometric sequence, you've got a common ratio. And if you know the first term in the common ratio, or really any term in the common ratio, you can find the nth term. So there's just a quick review of geometric sequences.